right, welcome everybody to week 4, day 3. I just wrote one of the world's ugliest for loops here. So you can do lots of horrible things with for loops. I don't recommend them. So what we have here is a for loop that starts with an empty string, loops until it equals and then adds, it appends one letter at a time to the end of the string, and each time it runs it does hello world, and you can see it'll work just fine. Don't recommend it. Just like you could do a for loop like this for float f equals 0, f is less than a million, f plus plus, cout, hi. You could do that, and in fact it probably will give you exactly a million. It'll probably give you a million lines of output, but computer science people don't. We don't do this. We don't use floats in control structures because of the error involved, and we just don't want to deal with the fact that sometimes when you add 1 to a number, you could add 1.01 or 0.99999. We don't like that very much. So due to the way the IEEE floating point number format works out, in this case it's actually safe to do probably because there's enough digits of precision in there that it'll be fine. But this just fills computer science people with nervousness and dread, because if we have a for loop where we want to run it exactly a million times, we don't use floats for that, So we use ints. So by default in like control structures and things like that, we use ints because they're deterministic. We know how they behave. Floats we use for like numerical simulations and things like that, for temperatures and in video games. If you're doing lighting, it's all done using usually 32-bit floats. There's options for 64-bit floats if you need more precision, and they've added support a few years ago, 7 or 8 years ago. They added support for 16-bit floats, lower precision floats, because a lot of times when you're just printing a color to the screen, there's only 8 bits of red, 8 bits of green, 8 bits of blue, unless you're in HDR mode. And so do you need a 64-bit float to compute an 8-bit integer? Probably not. And if you are off by 1, who cares? Like the human eye really can't see the difference between red 123 and red 122 very well, So if you want to speed it up, you can use a lower precision float. It takes up less RAM, and you can probably process them a little faster. Adding ints to GPUs is actually a fairly recent invention, I believe. Having GPU int support, I think, was fairly support. I don't remember when that was added, but I believe that actually was a fairly recent addition where you can actually do integer math on a GPU, because it was always floats by default for a long time. Okay. But in general, in C++, you're going to be wanting to use integers as kind of your go-to type, right? We typically, it's the vanilla ice cream. There's nothing wrong with them. Just be aware that if you go too high or too low, you're going to overflow or underflow. You're not going to get decimals, So if you try doing integer, division, you lose everything after the decimal. But ints are very well understood by computer science people, so we just tend to use them because they always give you the same result. Whereas with floats, if you do the arithmetic in a different order, you can get different results, and that just causes like these muscles right here around the heart to just start clenching, like like I want my code to behave the same way. If it behaves differently, that's really bad, Ideal is 100% of the time your code works. Next ideal is 0%. Having your code work some of the time is extremely stress-inducing. Okay, so the const keyword, because I just started the recording over, the const keyword, it makes a variable read-only. And we typically make our keywords all caps, like points per touchdown equal to 6. And we do this to prevent this from changing accidentally. Right? If we have a lot of code, there's a possibility that somewhere in there someone is going to mess with the variable and change it accidentally. And if you make it const, it just prevents it. The compiler will come in here and you have to say constant points per touchdown, and then the compiler's like, nope, can't do that. You cannot increase the value points per touchdown. It is const qualified. Const qualified means you have made a const. If you try compiling it here, G++ says increment of read-only variable. Can't do it. Not allowed. Okay. The only place where you can set a const variable is when you make it. Right here. Can't do it on the next line. If you leave it uninitialized, that thing is permanently uninitialized, right? You can't set it later, right? Can't do that. So, and always get into the habit of initializing your variables. In the previous class, a guy posted a thing saying, "Why is my loop not working?" And he had an uninitialized variable. It's something I keep saying to my students, like always initialize your variables, you know, and it's just less typing to not initialize them. Trust me, always initialize your variables. It'll make your life much happier. Okay. This isn't some big theoretical point. I've been teaching computer science for a long time. Please initialize your variables. It's really important. Okay, so you will see const come up in a lot of different contexts. All of them mean the same thing. Const means read only. Okay. Const means you can read from it, but can't write to it. Okay. So we can read from it and add 10 to it and stuff like that, and works just fine. You just can't change it. So if we try doing a plus in here, it won't work. Okay, so let's talk about the difference between plus and the pre-increment and the post-increment operators. So in the previous class, a student asked, they see a lot of code online like this. Going to do something 10 times, they'll see that. And that's a very common thing. In the previous class, I pulled up Godbolt, which shows you the assembly that's generated by the code, and it actually did generate the same code as that. They actually compile down exactly the same way. The difference between the prefix, the pre-increment and the post-increment operation literally doesn't matter when there's nothing else on the line. So if you say int x equals 0, x plus plus x, these two lines of code generate exactly the same assembly. Okay, there's no difference in them. When they come up is when you embed them in a complex operation. And I recommend at your skill level not doing that. Don't embed the prefix or postfix operations into any complex statement, because there's some weird hidden side effects that can come and bite you if you do that. So you'll see things like this, and that's maybe okay. Like if you're not doing anything too wild, like I'll allow that. And so what this is going to do, it's going to print the value of x, then afterwards increment it by 1. And so x will be 1 after this statement. So if we see out x now, so this will print 0, this will print 1, and then if we do this prints x, then afterwards increments it. This one increments x, and then afterwards prints it. So that's the difference between the pre-increment and the post-increment operator. If you do the x plus plus, it increments it after the print. If you do plus plus x, it increments it before the print. So this will print out 0, and then after the statement's over, x will be 1. This will print 1. This will increment it before printing it, so x becomes 2, then it prints it. So it's going to print 1, 1, 2. Sorry, 0, 1, 2. Because that's going to print 0. All right, it prints 0, then it increments it to be 1 afterwards. This prints out 1, then that increments it to be 2, and it prints out 2. Okay, so it prints out 0, 1, 2. Okay, but x is 1. X's value is 1 after that line. Okay. Do you guys understand the difference between plus and plus? The pre-increment and the post-increment? The reason why people do this, by the way, is because in C-Sci 41, you're going to learn these things called iterators, and It's arguably more efficient to do the prefix than the postfix on them because it doesn't have to generate a temp. I'd be surprised if the optimizer can optimize away the difference. So I don't think I don't know. I could be wrong on it, but I don't think there's honestly any difference between that and that. I write I++ like that because the language's name is C++. Right? So it's not plus C, it's C++. So I write my variables as I++ for that reason, because the language is called C++. That's it. Frankly, though, it makes no difference. If you look at the assembly code that's output, they're the same. And so you will see, though, people will do that, and it's fine. It's just purely up to you. Okay. They're both fine. Okay, so let's talk about functions. Okay, and functions are like an algebra. And there's a lot of functions that come in something called the standard library. There's the core language versus the standard library. So what comes with C++ if you don't include anything? If you include nothing. No include statements whatsoever. That's the core language. Okay? And so x equals 0. And x equals 0, it's fine. Double temperature is equal to 1.1, it's fine. Float f is equal to 3.1415, it's fine. It's all compiling, right? Strings. String s is equal to hello world. Nope, doesn't exist. Strings are part of the standard library. So what's the difference between the core language and the standard library? The standard library is a bunch of code that comes with every distribution of C++. Every time you download a compiler for C++, if you download it on Visual Studio or G++, or Clang, whichever compiler you use, MingGW, there's a bunch of different C++ compilers out there. All of them will come with a bunch of code that's already written for you that does a lot of the common stuff. And so common stuff includes like outputting to the screen, reading from the keyboard. Those are actually really complicated things, and I'm really happy that I don't have to do them. That's all found in Iostream. That's not part of the core language. If I try couting something, cout s, it's like, I've never heard of this. I've never met this man in my life. You know, Loki, Thor Ragnarok reference. So yeah, it doesn't know cout, doesn't know inline. Never heard of these people. That's because they're not part of the core language. The core language is very, very limited. And there are strings in the core language, but they look kind of weird. They look like that. Because that's how the C language did strings. So it's called a const char if you want to hold hello world. And my advice is just not worry about that too much right now. At some point, we'll need to explain how C does strings because it's kind of important. Because C++ is kind of layered on top of that. And if you're going to pass the string to like Linux, like the kernel, you have to pass a C string to it. So it's kind of important for a C programmer, for the C strings to be relevant to a programmer these days. But not on week 4. You're still learning the basics of C++. Stick to the string class, which is so much nicer. Okay. The string class didn't exist, by the way, when I was learning C++. We had to do our strings that way, and it sucked. It was really terrible. These things, you can't... there's so many things you can't do with it. Like, I know you've all been messing with strings, and, like, yeah, most of them don't work with, like, all those find functions, and, you know, s is equal to s plus s, right? Yeah, oh, you can't... you would think this is going to concatenate the strings. It doesn't. Yeah, so let's just not worry about that for now. Let's not worry about the old school strings. What else is in the language? Short, char, if statements, while loops, break, continue, for loops, you see how all these things are highlighted? Yeah, it's telling me this doesn't do anything. I know. I didn't want to do it. I can't see out anything. I don't want to. Temp plus equals 100. There you go. So, yeah, all of these things, and that's a for loop that does nothing, by the way. All these things are part of the core language. Anything highlighted in green or yellow is part of the core language. These are called primitive variables sometimes, or built-in variable types. It's not very big. Like, you can actually learn the entire C language in probably a day. The entire specification, especially if you're not learning any of the standard library stuff. If you just want to learn the core language, that's a day's work. It's 20 pages long, maybe. And once you learn functions today, you're going to know everything in the C language and the C++ language other than arrays and classes. And arrays are just making multiple variables at the same time, and classes are a way of grouping together variables. So they're just same thing you can do. It just kind of makes organization easier. Like if you want to make 1,000,000 ints, it's a lot easier to do int array 1,000,000 rather than int x, y, z. You know what I mean? So basically, after you learn functions, you're gonna know everything important in computer science. Week 4, you're done. So, perfect. Yeah, show that meme on the stream. So there you go. Absolutely. I've never written a for loop like that before today. I'm dead serious. I don't ever recall using a for loop in a float for for loop before. So, yeah. So you can tell when something's part of the core language because it's highlighted. String is not, right? Cout is not. These are all part of the standard library. The standard library is a bunch of code that comes with every distribution of C++. So every time you get a compiler, there's a bunch of code that comes with it that does common things to make your life easier. For example, there is no POW function by default in the language. If we say x is equal to x to the 10th power, it won't compile because it's not part of the core language. But there is a library called CMath. The CMath library, it's called CMath because it's literally the C language's math library that C++ stole. And that includes functions like POW. Okay? And so this will compute x to the 10th power. Okay? And you could probably write it yourself. You could probably do a for loop, or something like that to compute it. But yeah, without including anything, there's really not much you can do. You can't even output anything to the screen. That's not part of the core language. There's only one thing you can do that makes your code useful if you have nothing included, and I'll show you in a second. So let's see what we got here. X is equal to 0, S is equal to 10. Okay, so we're going to say 10 times X is equal to X plus S, or alternatively, I can just say S just like that, X plus equals X. So this is going to add 10, right? S is 10. It's going to add 10 to X 10 times. So X is going to be equal to 100. And then I'm going to return it. So remember, main is a function. Like in algebra, a function is something that takes in values and returns a value. And so we're going to actually return the value of x. It's the error code, but whatever. Unix limits the error code to be between 0 and 255. It technically is a char, not an int. It's an unsigned char, not an int. But whatever. C++ thinks it's in it, so we can return an int, whatever. And so this is going to return 100. And if we compile our code and run it, do you see how fast it compiled, by the way? That is fast. That's some fast compilation times right there, right? So if we were to time our compilation time, that is 0.04 seconds. That is some fast compilation time. And if we run it, we can view the error code like that. And the error code is 100. So that's the only way we can get something useful out of our program without using any of the standard library. Just the value that's returned. There's nothing else we can do in C++ except return a value from main. So it's not very useful. So we're always going to include something. And the trouble with including things is that it slows down your compile time, because literally Iostream is a giant file. This is a giant file. It doesn't look like it. It's just, I'm just including Iostream, right? But if we were to do this and compile our code, the compilation time went from 0.04 seconds to 0.4 seconds. So by adding in Iostream in there, it slowed down our compilation time by almost half a second, about a third of a second. It slowed it down. And if we start including more and more stuff, algorithm, which allows you to sort data, and tuple, and utility, and CMath, and there's a bunch of headers out there. And part of what we're going to learn today is where stuff is. Are you yelling at me for CMath? Thank you. If we do all that, then the compilation time is now 0.5 seconds. And if you wanted to include the entire C++, every header in C++, all in the standard library, there is this little hacky thing here. This is not part of the standard. This does not work on every platform, but you will see people using this on websites, so I have to talk about it. If you include bits/studc++.h, this will include everything in the standard library, all at once. And a lot of students like it because then you don't have to remember where stuff is. But if you were to do this, it slows your compilation time down to 1.5 seconds. Okay, so rather than 0.4 seconds, it's 1.5 seconds. Is that bothersome to you? I don't know. It's not too bad. It's really not too bad. But it's a second out of your life. I don't know. A lot of times you'll spend more than a second trying to hunt around for like where stuff is, right? And so, especially for like stuff that I use a lot, like Iostream, like I don't have to think about that, or CMath, I don't have to think about that. I know where that stuff is. But if you were to ask me like where some obscure function is, I don't know. So my friend is named cppreference.com. They search for CPP reference, and this is a thing that programmers do. Programmers are always hitting up documentation online. There are some weirdos that have the entire thing memorized. I'm not one of them. If I want to know where optional is, I'm going to guess optional. Yeah, okay, it's an optional. Formats and format probably. Yeah. I can guess these things pretty well. Map set, unordered set is going to be an unordered set. Yeah, that's reasonable. It's a weird one is going to be, okay, so there's tuple. Tuple holds multiple values, like 3 values or 4 values or something. That's found in tuple. But there's a special case of tuple called char that holds just 2 numbers, and that one's in utility for some reason. I'm not sure why it's in utility instead of tuple, because it's more or less just a special case of tuple. Tuples can hold 3 values or 4 values or 2 values even. Pair is specifically a tuple with 2 values in it, but it's in a completely different header file. I don't know why. And I don't know what utility means either, right? So, just, I don't know. Just stuff they couldn't figure out how to, forward is in utility. I don't know. I don't know why they put it in there. But that's what documentation exists for. So you can see I've got various links on here that have been highlighted because, I've been looking at the atomic operations library, which allows for thread-safe operations. Numeric limits, if you want to find out what the maximum floating point number is, you can do, it's in here somewhere, but that's found in limits. So if you don't like having any limits, don't include limits. So there's a bunch of documentation, and the standard library is fairly expansive. It's not as big as like Java's standard library. Java's standard library has more stuff than C++ is in it. Whether or not that's a good thing or a bad thing, I don't know. But it is bigger. But there's a fair amount of stuff in the C++ standard library. Yeah, so the angle brackets, when you do include angle brackets, this means the angle brackets mean it is a system install library. So if you have something in your if it's something you made yourself, like my read library, double quotes mean it is a user made library, and it searches your local. So it searches in different directories for them. So if you put angle brackets in here, it's going to search. There's a specific, was it varlib include or user include? Yeah. So no, user include math. No. Where is it? User lib. Go to cmath 30. These are all boost things. Yeah. Weird. Okay, Iostream. User include boost. HPP maybe. No. There we go. User include. Yeah. So user include that. So there you go. There's Iostream. And Iostream includes other files. And so what happens is, and the reason why these things slow down so much is because when you do include Iostream, it searches inside of that directory, user include, for the version of the compiler you're using. And it finds that file and it copies and pastes the entire file into your file. So your program, like if you were to word count your program, my program is 72 lines of code. If you were to see how big your code is after you hashtag include Iostream in it, let's go to these other guys here, just Iostream, g++-e main.cc pipe into word count-l. So your code is 72 lines of code. The just Iostream, just to get C in and C out, added 44,000 lines of code to your program. And that's why it took a third of a second longer, because it had to parse 44,000 lines of code. You understand? So don't include files you don't need. There's a tool out there called include what you need. Use what you need? Yeah, include what you use. That's it. Include what you use. And so this is a pretty nice tool that will tell you if you're not using a certain include. It's like it goes through your thing and tells you if you're, hey, you're not using CMath. You can take it out. And so it's a tool that you can run on your code to kind of clean up your includes so you don't slow down your compile time too much. And then some people will just do the bits. And then some people just do that. I don't have to worry about include things anymore. So it is now 143,000 lines of code. So, that's all the standard library, more or less. Okay. But yeah, don't do that. Is my advice. You can. I mean, I'm not really going to say anything, but I wouldn't do it. Okay, so let's see how much CMath adds. CMath adds another 8,000 lines to that. My read library adds another 5,000 lines, because my thing includes other things as well. So, okay. So anyhow, core language versus a standard library. So the core language is very, very small, and it's small for a reason, because if you want to use C++ in the world's smallest computers, 20 lines of code. Okay. And because it's actually smaller than before, because the preprocessor -e runs the preprocessor. That's the thing that does the hashtag include, all that stuff. It cuts out the comments too. So I actually only had 20 lines of code in there. So rather than yeah, so let's see how big the thing is actually. Let's see, -o space 19 lines of code. All right. So this made an a.out that is 19K in size. Really? 19K? Actually, no. It's because I'm still doing this. $16K in size. Okay. That's really big. Surprisingly big, actually. On the Raspberry Pi, I can get it usually down to about a K. So it's actually making an executable that is 17K in size. And so this is actually already too big to run an Arduino. So an Arduino, which is these... got one of them around here somewhere. Have you ever played with Arduinos? Have you guys seen Arduinos before? And yeah, you don't need C-outs for like TV remotes and things like that. Like the embedded systems world is people program these things, right? Like there's a temperature on here and there's different buttons you can hit, and when I hit power it turns off my split unit there and stuff like that. So somebody's written a program for this, but you don't need C in and C out. The only output is like the little LCD display here. There's no console, there's no graphics, so it just has probably a very simple embedded processor on here. Arduinos have, you've held one, never used it. Yeah, Arduinos have on the order of about 8K of RAM. So, and you can buy the chip, the Atmel chip. You can buy it for like a quarter, something like that. So you can buy a CPU real cheap. Atmega cost. So yeah. So $3. Okay, $3 for this one, $16 for that one. Interesting. There's got to be cheaper ones out there, right? Stock. They're out of stock. 900 on order. Yeah, CPU. There is a shortage in silicon right now. Real bad. $12 each. It's ridiculous. No, these are like real CPUs. Yeah. Anyhow, the point is that you can get these embedded CPUs for like real cheap, and the reason why you need them to be cheap is because if you're going to be selling a kid's toy for a couple bucks, you can't spend $80 on a Core i7 or something. You know what I'm saying? So, do Arduinos use C? Yes. Arduinos are programmed in C by default, and so you can't, like this is already too big to run on an Arduino, right? And I'm actually curious what is going on inside of here. Why there's so much stuff inside of here? Huh. Interesting. Yeah, it's including libc, which... Or is it init? Libc start main. Interesting. I don't know. Yeah, it's bigger than on the Raspberry Pi, that's for sure. So yeah, Arduinos use C, and they have like this Arduino Studio, and you hook up your Arduino via USB cable to your computer, and so you do your programming on your real computer, and then it downloads through a USB cable onto your Arduino. And so there's all sorts of cool stuff you can do with that. And if you take CSI 45, you'll learn more about this then. But like every year, my daughter does a project. We like doing builds together and stuff like that. And so for her second grade one, we did like a coral reef diorama using Arduino. Yeah, here we go. So your diorama is coming along nicely. Yeah. We have a big nose. We have a servo. What is the servo going to be used for?
It's a bird.
Pass your bedtime.
That's 9.
10 o'clock.
Oh.
So you can see there we have an Arduino set up with some LEDs.
So
My daughter's gluing
what
like
are we going to use that servo motor for?
a fish onto it, and we have the Arduino controlling the brightness and intensity of these LEDs, and then we there she is wiring it, and there's the coral diorama, and
So your diorama is,
let's see,
what else?
I don't know, wherever. I have a video somewhere of the final project, but basically we put the LEDs into the shoebox, wired them to the Arduino. The Arduino would control the brightness of the LEDs, so they would kind of go like this, brighter and dimmer, so simulating like the caustics of an underwater scene. And then we had a servo motor hooked up. I programmed the servo motor, my daughter didn't, but she set the parameters on it, the frequency and amplitude of the wave. We basically did Trig. She doesn't know Trig, obviously, in 2nd grade. And basically the servo motor would kind of move in a sine wave, and so she controlled the amplitude and how often it moved, and then she glued a fish onto it. We drilled in through the back of the shoebox and had this fish kind of swimming around with the lights kind of going like that. And it was really nice. It was and I just sent it off to school because Arduinos are really cheap. Like if somebody was going to steal it, right? Like actually, now that we're in a pandemic, I don't even know how much these things cost now. Okay, Arduino Uno, $23. Okay, yeah. So okay, you can get a microcomputer or an embedded computer, however you want to put it, for $23, and it's got all these pins that you can wire things up with. The Atmel chip is here. It's got a USB Type-C connector there. It's got analog in, so it can read from sensors of different kinds, power that you power it with. And you've got digital outputs here, and a couple PWM pins, so you can control the brightness of LEDs and things like that. Really easy to program, suitable for like elementary and middle school kids, no problem. And the point is that it does not have much RAM on it. So something like that would be too big, right? So that's another reason why people control their includes. You know, if you work in the embedded space, they really care a lot about keeping everything small. Because if you have to buy a bigger CPU, that adds to the cost, right? So now your remote control is going to cost $10 instead of $5. You know what I mean? And so that is a huge competitive disadvantage. You know, so you have to keep everything in the embedded space small and cheap. Okay, so let's talk about what functions are out there. So of course we all know Iostream, and using namespace std. For C in and C out, we have worked with include CMath before as well. So let's talk about the options that are in both of those. Iostream has C in and C out. I don't really need to go into that. But there is abs. Abs is absolute value. So you'll see sometimes people talk about fabs and abs and labs and abs, fabs with an F. And the reason why they have all these different versions is because in C, every function has to only take one type. In C++, you can have an absolute value function, abs. You can have one version for ints, one version for doubles, one version for floats, one version for longs, things like that. In C, you can't do that. And so in C, they just have to make a different function for every type. And it's really, it's really tedious, you know. So they have a long absolute value of fabs, takes doubles. It doesn't take floats. You think it takes floats. It takes doubles. The F stands for float, but it takes a double. And then they added in C99 the F abs F, which is the float version of float absolute value. At some point, they're probably like, all right, dang it. We should have called it dabs. You know, that would have been amazing, but it should have been dabs, yeah. But you know, you just noticed somebody on the C committee was like, dang it, We need to make a floating point version of absolute value, and f's already taken. Should we call it fabs? Or so they just called it fabs f. And so you just know that somebody's brain hurt a little bit when they're making that. Labs is kind of cool. Long absolute value. Yeah, but all these things are just abs. So in C++, you can do abs with ints, doubles, shorts, chars, whatever. And so if you have a negative value here, like here, we are going to subtract 10 from x. 10. We're going to subtract 10 from x 10 times. It's going to be negative 100. But if we absolute value negative 100, then we get 100. Okay. So that's absolute value. And then, of course, we've got tau. If we're going to take x to the third power, then we get negative 100 to the third power, which is that. Negative 1 with 6 zeros on the end of it, which sounds right to me. 222. Yep. Okay. So tau returns a double, by the way. If we wanted, we can convert it back to an integer as such. And we got negative 1,000,000. Or okay, fine. I'll be proper static cast measure. There you go. Okay, so yeah, POW, abs, all the trig stuff is in there. So if I wanted to see out the cosine of 0, it's cos, cosine of 0, sine of 0, tangent of 0. So cosine of 0 is 1, sine of 0 is 0, tangent of 0 is 0. Do they have inverse trig functions? They got stuff. They got the hyperbolic, and if you want to look up all the things available, they've added a lot to C math as well. A lot of stuff that I don't even know like what it means, and it's kind of baffling to me that they're adding like, what is this, mathematical special functions. So they added Bessel functions and Legendre polynomials and modified some, and they're not adding like, you know, inputting variables in a normal fashion. Like, like I don't know where their priorities are at, to be perfectly honest. I honestly don't know. So yeah, if you want to do a Hermite polynomial, you can do that now. I don't know what it is. Okay. But if you want to look at just C math and all the options in there, common math functions are here. Abs, fabs, and all the different versions of that. Max, min, exp is e to the x power. 2 to the x power, logarithms, log base 10, log base 2. This is natural logarithm. POW, square root, hypot is pretty nice. I use that all the time. That does the Pythagorean theorem, right? So, hypot's nice. Doesn't have anything to do with getting high on pot, fortunately or unfortunately, depending on your perspective. So trig, sine, cosine, tan, arcsine, arctangent, hyperbolic sine, inverse sine. There you go. Inverse hyperbolic. Sorry, it's not inverse sine. A sine should be in here, maybe. Sorry. Yeah. Yep. And they take radians, by the way. So if you're wondering if these are radians or degrees for 0, the answer is yes. But if you tried doing like 90 here, you're going to get the cosine of 90 radians, not 90 degrees. Yeah, so Yeah, you can. It's really nice to just be able to pull up CPP reference. CPP reference is your friend. Pull it up, and you can just go through all the different options that are in there. It's like I said, it's reasonably complete. Like they got most of the common stuff you'd want in there, with some notable exceptions, like printing colors to the screen, playing a sound, reading a mouse, contacting the network. Well, technically, they do have network code in the C standard library. And C++ can use the C standard library. But like things like reading a mouse click, or drawing a square on the screen, or changing the color of fonts. Nope, no support for that whatsoever. Open up a window. Nope, no concept of that whatsoever in C++ in the standard library. You have to get a third-party library to do that. And to me, it's one of the worst parts of the language. Okay, so let's do the cosine of like 3.14. Actually, let's teach you the right way of doing it, which is called m pi. So cosine of pi, basically. So m underscore means math. So this is a constant called math pi, and it will do. It's what you expect. It's 3.1415. So the cosine of pi is -1. Cosine of pi, the sine of pi is 0. Notice how we didn't get 0 there. Floating point numbers, look at that. Rounding 1 times 10 to the -16th power. Okay, and tangent is also giving us something very close, but not equal to 0. So don't expect double equals to work. Greater than equals, less than equals, yes. Fine, absolutely. Okay, so that's in there. Good enough. Let's learn how to write our own functions. Okay, so just take all this stuff out, I guess. Okay, so let's learn to write our own functions. Okay, so in C++, you can. This is the syntax for writing a function. Okay, so in algebra, you guys have all taken algebra, right? In algebra, we would write on words, on pen and paper. We'd write f of x is equal to, if we're converting from degrees to radians, right? X divided by 180 times pi, right? Is, if you want to understand why that works. So degrees divided by 360 times 2 pi, right? So if you have 0 degrees, you have 0 radians. If you have 360 degrees, you have 2 pi radians, right? So this is how you do it in algebra. Okay, so let's see how we would do that in C++. So this is a function, right? In algebra, this is a function named f. It takes one parameter named x, probably of type double, I guess, because that's what numbers are in algebra usually. And then what is it going to do? It's going to compute that value divided by 360 times 2 times pi and return that as the result. Okay. So in C++, the syntax is this. You first say what the return type is. So what do you think the return type? What do you think the type of the returned value should be? What do you think? We're taking in x as a parameter. It's probably a double. And we're going to be returning that number divided by 360 times 2 times pi. What do you think the return type should be? The type of the returned value. Float, double. Yeah. Both would work. I'd say double. Then you come up with a name for the function. This is the hardest thing in writing a function. It's coming up with a good name, right? If I was a math person, I'd be like, F. I'm done. That's the name of the function. F. Everything's F. Unfortunately, we can't do that in computer science because then we would have just a bunch of functions called F. And sometimes G, sometimes H, because that's it. In math classes, it's always F. And if you've run out of F, it's G. So no, we need to come up with a better name. So we'll call this one degrees to radians or something like that. Okay. Then, so the first thing when you're making a function is, and we're up above main, by the way. We're up above main. We're not in main. We're up in the global space above main. So the first thing is the return type. The second thing is the function name, degrees to radians. Then we have a parentheses. The parentheses tells C++, this is a function, by the way. It's very important. And then we list what kind of inputs the function have. What kind of parameters are coming in. And they're separated by commas. So it's a parameter list separated by commas. And so if we wanted to have an int x and a string s, it would look like that. So within the parentheses, you have a list of all the variables that are being passed into it. And for this one, we're only taking an x, and the type of x, like I said before, is double. So we're just going to call it x. Could call it degrees. Call it x, whatever. I don't care. And then you have to have the curly braces. Okay, so the curly braces are essential. You cannot omit them. So you can't even if you have a one-line function, you cannot skip the curly boys. Okay, you have to have them there. They're part of the definition of a function. So the syntax for a function is return type, name of the function, parameter list, and then curly braces with whatever it is you're going to do on the inside. Okay, and so all we're going to do on the inside is we're going to return a value. So a function usually takes input and then returns a value back. And so we're going to return x divided by 180 times pi. Math pi. Okay. And so I just simplify this down. Divided by 360 times 2 is like divided by 180. Something like that, right? So that is that. So I have now created in C++, I've created in C++ the equivalent to this function here from algebra. It will take in a degree and it will return a radian. And like I was talking about last class, degrees are actually a lot easier to work with from a user's perspective than radians. I work a lot with Unreal Engine. You might have seen me post the Laser Zombies, my game jam project here. So my daughter did all the world building and stuff for it. Yeah, so beautiful Fresno era, right? So in Unreal Engine, you do everything in degrees. And it was always kind of like weird to me. It's because like in the standard library in C Math, everything's in radians. And so you would have to constantly be converting between degrees and radians to get any work done. So I was like, why didn't they use radians for stuff? And then when I started rotating things by hand, like you can punch in, like rotate it by 90 degrees, I realized degrees are a lot easier to work with, you know? Like if you had to enter like 90 degree, like rotate 90 degrees, in radians, you'd have to pull up your calculator every time, right? And go like pi divided by 2. And then how many digits do you type in? You know what I mean? Like 1.57, 1.5707, 1.5708 to round it. You know, like there's no, like, or just, you're going to just copy this or something, you know? Every time you want to do a rotation, you'd have to open up a calculator and do it. Forget about that, you know? Forget about that. Degrees, you just punch in, rotate it 30 degrees, whatever. It's not an infinite irrational number. It's just 30 degrees. And so it's actually a lot easier to work with doubles as a human than it is to do radians. Like I know why radians exist, and it makes doing some of the math stuff easier and stuff like that. But yeah, degrees are actually much more practical from a user interface standpoint. And I didn't really think about that until I started really working with Unreal Engine and just typing in, okay, rotate 45 degrees, you know. If I had to do that in radians, I'd have to be like, okay, hang on. Copy, go into Unreal Engine every bloody time, you know. Or if I typed it in manually, I'd get error every time. Because I can't type infinite digits. I can type 45, I can't type an infinite digit. So, you know, or even if you just run it out to 15 to 17 digits for a double, that's still way, way, way more annoying than I want it to be. So, all right, so here we have a function, degrees to radians. It takes in a double as a parameter. It returns a double as the output. And this is what it does. So it's going to divide it by 180, multiply it by pi. It is a linear transformation, I think. Yeah, something like that. Okay, so cout, please enter the degrees you want to rotate the object by. And we'll have double degrees to 0. Always, always, always initialize your values, people. C in degrees, and then we're going to cout degrees to radians, passing in degrees. Okay, and so this is how you call a function. Okay, so we're gonna. This is all stuff you know. We're gonna put a degrees. And then we're calling our function like this. You give it the name of the function, degrees to radians, open parentheses. That's what tells C++ this is a function. Anytime C++ sees something that looks like that, it is going to look for a function named f. Okay? The parentheses mean function call. Unless it means something else, which isn't. You'll learn about in 41. But this means a function call. We're calling a function named f. Okay? So... and we're passing into it this variable here, degrees. Okay, so it's going to call the function, it passes in whatever the user types in, and then it's going to jump up here, it's going to run some algebra, and then it's going to come back here and output the result. So this whole chunk of code here, if I passed in 0, that whole thing would be replaced by the number 0, because 0 degrees is 0 radians, right? So you call the thing, it comes back, 0 was returned, so it couts 0. Do this. If I wanted 0, 180 degrees, pi. 360 degrees, 2 pi. 45 degrees, pi over 4. 90 degrees, pi over 2. Okay. You guys understand? So this is how you make reusable blocks of code. Reusable blocks of code. If you're ever going to be doing something over and over again, if you're going to be finding yourself converting from degrees to radians over and over again, like I'm sure Unreal Engine does, unless they made their own math library that works natively in degrees, which they might have done. But if they were using like the standard library functions, every time the user says rotate by 180 degrees, they've got to do that algebra. And they could, I guess, write this little snippet of code over and over again, but that's garbage talking, right? If you're ever using the same chunk of code over and over again, you make a function out of it. And then you can call the function here, and there's only one place where you have to maintain that code, right? So if you ever optimize it somehow, if you come up with a faster algorithm, then you only have to change it in one place instead of control Fing and finding all a million places where you converted between degrees and radians. You guys understand? So anytime if you keep finding yourself writing the same 5 lines over and over again, turn that into a function. Okay? Make a function out of it. You guys understand? Copy. All right. So it's not going to be lab time till 3:50. And so I want you to follow this pattern that I created here. Return type, function name, parameter list. You're going to get a Zybooks on this, by the way. It'll be due next week. No class on Monday. It's Labor Day. Your homework times table is due on Wednesday. If you have any questions about times table, post it during lab time. Otherwise, I want you guys to write the following 3 functions. So I want you to write a function that converts between Fahrenheit and Celsius, and vice versa. So mine is called degrees to radians. You can call yours Fahrenheit to Celsius, or if you don't know how to spell Fahrenheit, call F to C. That's fine too. It's also probably going to be double, probably. And you can call it Fahrenheit to Celsius if you want, or you can call it F to C, or you can call it freedom units to communism units. whatever. So you're going to make one function to convert from Fahrenheit to Celsius, one function to convert from Celsius to Fahrenheit, then down here in main, do this kind of thing here. Read in a couple values, switch between Fahrenheit and Celsius, test it out, test it on 32 degrees, make sure you get 0 degrees Celsius, and then and for this one, use ints instead of doubles, just so you get practice. So you understand not everything's a double, right? So just for this one, just use ints. Kelvin to meters. How about Kelvin to color? That's a good one, right? That's an actual thing, 6500 Kelvin, right? Is a different colors are based on the Kelvin. So my water meter outside says something like 40K on it or something like that, or 10K. And so I always joke that it's Kelvin, so it should be ice. Not a very good joke. Sorry. All right, so that is your lab time. Again, if you have any questions about times table, post it. And so yeah, so you're gonna write 3 functions, and then after you've written them, screenshot them working, and you can leave. Okay. Just follow this pattern. Okay. So converting Fahrenheit to Celsius is going to be very close to this, except the equation is going to be different. Any questions? I'll come back at 3:50 and I will type in the answers then. Okay. The third function is this one. So Fahrenheit to Celsius is 1, Celsius to Fahrenheit is 2, and then this one's the third. Okay. All right. I'm going to pause the recording now. I'll come back at 3:50 and show you the answers. Have fun. All right, we're recording again. I used this illustration in my previous class. You've probably seen something like that in algebra before. Your algebra professors probably drew like a box, and there's like a number going in, and then it like cranks and computes for a while, and then a number comes out. That's basically what we're doing with these functions here. It takes a number as an input, gives a number as an output, and use the return keyword to return a value back to whoever called the function. This needs to be up above main, not inside of main. That's a common mistake that people make. They write their functions here. It needs to be up here. Okay, so let's go ahead and do these. So we wanted Fahrenheit. Probably salvage some of this. And Fahrenheit. There we go. Call this F2C. So I'm going to write a function double F2C that takes in a double X. I don't know. And we're going to return Fahrenheit to Celsius is, the equation is X minus 32 times 5 divided by 9. And the equation for Celsius, or communism units, is let's see, times 1.8. Yeah, you can do that as well. Oh yeah, let's see, that's a double, so it should be fine, but yeah, should be good. And then the other way around, you take Celsius, multiply by 9/5, x times 9 divided by 5, plus 32. And yeah, okay. And then for this function here, we have int, as I said, use ints named f, int x, int y, and we're going to return pow of x2, which is x squared, plus x times y, plus pow of y squared, or we can do x times x and y times y. Either way, it works fine. And there you go. There's the stuff. Do you guys have any questions about it? I can run it, I guess. Celsius. type in 32 degrees, I get 0. If I type in 100 degrees, I get 37. Or 30 degrees is 50 something. Yeah. So there you go. That's our first crack at functions. You can make functions to make reusable bits of code, and you can call them by using whatever name you came up with, and then in parentheses passing in whichever parameters are required for it. So if I wanted to do the same thing here, and Celsius. Doesn't matter where the functions are declared, they have to be above main. Next week I'll probably show you how to put them below main, but for now they have to be above main or won't find them. It goes down. I keep getting 0 no matter what I enter for Fahrenheit. Remember, if you do 5 divided by 9, that's 0. The reason why I'm not getting 0 is because I've already this is a double. X is a double here. So double minus 32 is a double. A double times 5 is a double. Divided by 9 is a double. That's why I was kind of hesitating when I did that. You might want to try that, Otal. And just depending on the order that you're doing the operations, you could be getting 5 divided by 9, which is 0. Right. So that, and then cout, please enter x and y. And these are ints, so int x equals 0. Y equals 0. Again, please do not forget to initialize your values to 0. Literally at the end of last class, a student had a bug that was caused by that. And then we're going to see out f of x and y. One thing I should note is that you don't have to do them all in one line. Like functions can have multiple lines in them, right? So I could say int sum is equal to pow of x squared, sum plus equals x times y, sum plus equals pow y squared. I can certainly do this. This would work just as well. And there's no requirement that a function be a one-liner, right? You do have to have the curly braces, even if it's a one-liner, though. So sometimes you'll want to break down big, complicated equations like this. The way we had it before was fine, honestly. I'll just probably put it back there. And yeah, I'll put it back like that. But it is fine as a either a one-liner, or if you split it up into multiple lines, it's okay. Okay, so let's run this code. So 100 degrees in freedom units is 37 in communism units. 37 in communism units is 98.6 degrees. Boom. Please enter x and y. Why did that not work? Because I don't have a cin statement. That's why. Cin into x, cin into y. That would be helpful. Okay. 1, 1, and then if we type in 10 and 10 here, 10 squared plus 100 is 300. 1 and 2. 1 squared plus 2 plus 4 is 7. Yeah. There you go. So that's functions. Any questions? Questions about times table? We'll be due at the start of class on Wednesday. Okay. If that is all, then I wish you all a good weekend, and I will see you all on Wednesday. There's no class on Monday. It is Labor Day. So have a good 3-day weekend, and peace out.